can understand the cloud, we need to understand what the cloud actually sits inside. And it sits inside a building, a very specific, very carefully engineered kind of building called a data center. In this video, I'm going to show you exactly what a data center is, how it works, why it matters, and what the 5 terms are that every non-technical professional should know when someone mentions data centers in a meeting. There is a phrase that gets used constantly in technology programs. It's in the cloud. And most non-technical professionals hear that and picture something abstract, data floating somewhere in a digital sky. But the cloud is not abstract. The cloud is a building. Very large, very expensive, and very carefully managed building full of computers. And that building is called a data center. Once you understand what a data center is, the concept of cloud computing stops being mysterious and starts being completely logical. A data center is a large building, often the size of a warehouse or several warehouses. They exist for one specific purpose: to house computers. Not office computers, not laptops, but servers. Racks and racks of servers stacked from floor to ceiling, row after row, running 24 hours a day, 7 days a week, 365 days a year. The building is built around the servers. Everything about the design, the power supply, the coolant system, the security, the network connections, everything exists to keep those servers running. The first I'll be describing is a server. A server is simply a computer, but a computer that is designed to do one job: store, process, and deliver data to other computers on request. So when you open Gmail, your laptop sends a request to a server somewhere. That server finds your emails and sends them back to your screen. You never see the server, you never interact with it directly, but it is doing the work behind every website, every app, every file you access online. The key difference between a server and your laptop is availability. Your laptop sleeps while a server does not sleep. Servers are built to run continuously, reliably, and without interruption. So now we have 2 terms: server and data center, and they work together. The server is the computer, while the data center itself is the building designed to keep that computer running. But a data center is not just a building with computers in it, because any office could fit that description. A data center is a building that has been engineered specifically to guarantee that those computers never stop running. It has redundant power. If the main power supply fails, backup kicks in within milliseconds. It has precision cooling because servers generate enormous amount of heat, and without constant cooling, they would overheat and fail within minutes. It has physical security that would rival a bank vault. And it has multiple independent network connections so that if one cable is cut, traffic automatically reroutes through another. Everything about the building exists to ensure that network connection is continuous in terms of its operation. The third term is hyperscaler. This is important for anyone working on a cloud program. A hyperscaler is a company that builds and operates data centers at a scale that most people cannot comprehend. We have Amazon Web Services, otherwise known as AWS, that has over 100 data centers across more than 30 geographic regions worldwide. And then we have Azure and Google Cloud, which are also at very similar scale. These 3 companies, AWS, Azure, GCP, what most people mean when they say the cloud. When your organization decides to move to the cloud, what they are actually deciding is which of those 3 companies they are going to rent computing space from. You are not buying a cloud, you are renting a space in someone else's data center. The fourth is colocation, often shortened to colo. Colocation is a different model from cloud, and it is important to understand the distinction because both come up in enterprise technology programs. With cloud, you're renting a server that the hyperscaler owns. You pay for the compute time. You never see or touch the hardware. Whereas with co-location, your organization owns its own servers. But rather than housing them in your office building where the power and cooling are insufficient, you rent space inside a professional data center. You put your servers in their building and use their power and cooling and their network connection. You own the hardware, they own the building. This model is common for organizations that have significant existing hardware investments but want the reliability of a professional data center environment. The fifth term is redundancy. In everyday language, redundant means unnecessary, something you do not need. In technology, redundancy means the opposite. Redundancy is the practice of having a backup for every critical system so that if one fails, another takes over immediately and the people relying on the service never experience any interruption. A professional data center has redundant power, typically mains power plus diesel generators that start automatically within seconds of a power cut, plus uninterruptible power supply batteries that bridge the gap between the power cut and the generator starting. It has redundant cooling, redundant network connections, and the data itself is redundantly stored. That means the data is copied across multiple servers so that if one fails, redundancy is the engineering principle that makes cloud services reliable enough to run business critical systems. Let us put all five terms together so that you can see how they all connect. A hyperscaler, AWS, Azure, or Google Cloud designs and builds a data center. Now, that data center is engineered with redundancy at every level. And that means in terms of power, cooling, networking, and hardware. And this redundancy is so that it can run continuously without failure. Inside the data center, thousands of servers. Those servers are what you rent when your organization uses cloud services. Some organizations also choose co-location. That means they own their own servers but house them inside the hyperscalers or a third-party data center facility using its power, cooling, and network connections. And the next time someone in a meeting says, "It's in the cloud," you know the exact physical reality they are describing. Now, why does a business analyst, a PMO professional, or a project manager need to understand data centers? Because data centers come up constantly in the work you're already doing. Every cloud migration project involves a conversation about which data center region to use, and that decision has cost, latency, and compliance implications. Every disaster recovery plan involves a conversation about data redundancy and backup locations. Every vendor contract for a cloud service involves a commitment about where your data physically lives, which is a governance and regulatory question. The question, where does our data actually live, is not a technical question. It's a compliance, governance, and risk question. And understanding data centers is what makes you equipped to ask it and understand the answer. Five terms, all of them grounded in something physical: a building, a computer, a company, a model, an engineering principle, sub data center, hyperscaler, co-location, redundancy. The next video in this series is what is the cloud actually? Now that you understand what a data center is, that video is going to make considerably more sense. The cloud is not magic. It's not abstract. It's rented space inside one of these buildings. Subscribe and I will see you in the next video.